Hello and welcome to Salutary Spade. Salutary Spade. My name is Yuichi right? And I will be teaching you guys kinematic equations. And for those of you who don't know, kinematics are basically kinematic equations are basically equations. It's like taking from a toolbox that describe the. Actually, hold on. Let me just write a box around here. They're basically equations that it's like a toolbox where you don't need to really know any physics to get this, but these are equations that you can use to solve physics problems. Okay, and a lot of AP final tests use kinematic equations. You can use only kinematic equations and get through it pretty easily in classical mechanics. So this is obviously excluding like thermodynamics and electrodynamics and optics and that kind of thing. So first, I think I'm going to jump right into what these equations are, and you can write these down, take notes. Okay? So we have the velocity, which if you remember from the last video, velocity and speed are pretty much the same, except velocity has a direction. Okay? So we have v sub f, which f stands for the final velocity, is equal to v sub 0, which we'll get into what that means in a second, and then plus acceleration a times t. Interesting. Okay, so let's just leave that, and so we have velocity squared. This is the final velocity squared, is equal to VO squared plus 2a, and we're going to use, I don't know, let's use d, where d is distance, okay? Let's define all these in the corner here. Velocity. And actually, let's not use 0, which these stand for, the 0 means at time 0, but it really means initial velocity. Okay, so F is final and I is initial, okay? And A is acceleration, and then T is time, okay? And D is distance. We usually use R in physics for distance, but we'll use D for now. Alright, and then if we wanted to find the distance would be equal to one half the initial velocity plus the final velocity times t. Okay, and then we have distance is also equal to the initial velocity times t plus 1/2 acceleration plus 1/2 acceleration times t squared. Alright, and let me just remove this up a little bit so you can see that it's not as shadowed. Alright, so these are the basic kinematic equations that you will use. And now let's do some problems with these equations. And I hope that you're writing these equations down, because I am erasing them now. Okay, so let's start with the first one. Let's write it at the top. The velocity F is equal to the velocity of the initial plus acceleration times time. Okay, so hold on, let me think of a problem to use this, because I'm just doing this on the spot, doing this on the fly. Okay, so let's say that we have a car. Yeah, let's say that we have a car. Okay, let's draw the car like that, and the car is going to be accelerating. It's going to be accelerating at 3 meters per second squared, and it's per second squared because it's accelerating. And then, and let's say that it's going down this long road, okay? And the road is 400 meters long. 400 meters long. And then let's say that it takes, actually no, let's not define a distance. Let's say that it takes 12 seconds to get from one end of the road to the other, okay? And its initial velocity is 0. It's starting at rest, okay? So now I want to know at the point where it gets to the end of the road, what will be its velocity at that one point. And how do we solve that? Well, let's move this up here, okay? So how do we solve that? We can take the velocity final is equal, let's just plug in the numbers, that's all we have to do. 0, because that's 0 is the initial velocity, plus 3 times 12. Ah, that's pretty interesting, right? So then that means that the final velocity is equal to 36 miles per hour. Interesting. That was pretty simple, huh? So that's how you use the first equation. Now let's move on to the second equation. And I hope to do all these equations. Do at least one example with all these equations in this video. Alright. Now let's do almost exactly the same okay. So let's say that we have a what do you call those? Takeoff, airplane launch things. So we're at an airport, okay, and we have an airplane. Okay, and this is the airplane, and it has its wings, right? That's our airplane. And the airplane has to, so the runway, that's what I was looking for. The runway is going to be 400 meters long, okay? And then we know that in order to get the plane to lift off, okay, the plane is at rest right now, MPH, and we have to get it to 110 miles per hour in order for it to lift off. Okay? And so we need to know how fast does it need to accelerate in order to get to that speed. Okay? And I'm going to need my calculator for this. Let me just get my phone. Where is my phone? Where did I put my phone? My phone is right here. Okay? So I'll get out my phone. Hold on, my phone calculator. And first, let's write this out. Okay? So we know, and we're doing the second equation. Okay, so we know that we have distance. We need an equation that includes distance, initial velocity, and final velocity, but that and also includes acceleration. But we don't know acceleration. That's what we're going to solve for. And so we know that the equation v sub f squared is equal to the initial velocity squared plus, what is it? It's 2 acceleration times the distance, right? So now let's just plug these numbers in, okay? So the final velocity is 110 squared plus 0 squared plus 2a times the distance, which is 400. Now, let's go ahead and, hold on, let me make that one look a little bit nicer. Okay, so now let's just, let's do our arithmetic. I chose the wrong thing. Let me just plug it into my calculator now. Hold on. Let's just plug this into my calculator. So we know that 110 squared is 12,100. 12,100 is equal to 0 squared is just 0. 0 plus 800 times a, because we're just doing 2 times 400, right? And so what we can do is we can take the 12,100 and we can divide it by 800, which would give us 11,300 miles per hour, or 11,300. And hold on, what are we doing? We're doing meters per hour, right? Yeah, that's what we're doing. We're doing meters per hour. Meters per hour squared. And you usually wouldn't write acceleration in meters per hour. You'd usually do it in meters per second squared. And if we wanted to get meters per second, we'd divide by 360. So let's do that. 360, right? Because you'd take it, or wait, no, that's wrong. Excuse me, I'm doing this. So we take 11,300, and because there are 60 minutes in an hour, we divide that by 60, right? And so we get 188.333333333 miles per actually, that's too much of a hassle. Let's just leave it at that, okay? So we're going to leave it in this unit, okay? So this is 11,300 miles per hour squared, okay? Or meters per, I don't know. Whatever. I screwed up on the units. I wasn't even thinking. So let's ignore the units. Okay. We should have done it all in meters. I feel stupid now. That was a very bad example. But yeah, I think that you get the basic idea that you're supposed to, you're supposed to, what you're supposed to do with the numbers. Now let's work on the third, or let's skip because we have two distance equations. Let's do the second distance equation, which we know the distance, the initial velocity, the acceleration, and the amount of time it takes. So let's do another equation, or let's do another problem where we have, let me think about this, we have Sonic the Hedgehog, because why not? Let me just move this down. Sonic the Hedgehog, because why not? So we're going to draw Sonic the Hedgehog, and he's got his Sonic, and that's Sonic, okay? There's our Sonic. Okay, and he's running. Okay, he's going to be running, and he's running at, so he's going to be accelerating at 10 meters per second squared. 10 meters per second squared, so pretty fast. And then we have velocity. His initial velocity is going to be 0, so starting at a rest velocity, and he is going to be, and he's going down the street, and it takes him 5 seconds. 5 seconds to go all the way to the end of the street, okay? To the end of the block, and we're going to put a stop sign here. That's not a... I'm trying to make this an octagon stop. Okay, so that's at the end of the road. And so we want to know how long is the road? That's what I'm trying to ask. Okay, so we write down the equation for that, and if you remember the equation for that, that's distance is equal to the initial velocity, which is 0 times time, which 0 times 5 is just going to be 0. Well, let's just write this out first. Plus 1/2 the acceleration, 10 times the acceleration, 5 squared. Alright, so now let's solve this. So distance is equal to 0 plus, so 5 squared, order of operations says that we do the exponents first. We can do 5 squared is 25. And then let's just multiply these two. So we got 5 times 25, which distance is equal to 5 times 25 is 125. 125 meters. And that's how you use the kinematic equations. My name is Yuichi Gray, right? From Salutary Spade, whatever. And I am signing off now.